Okay, question 22. This is going to be a harder type of Atwood machine problem that requires a little bit more thinking. So a 3 kilogram counterweight is connected to a 4.5 kg window. So we're saying this guy is the window, so 4.5 kg, and this is the counterweight, so 3 kilograms. Connected to a 4.5 kilogram window that freely slides vertically in frame, how much force must you exert to start the window opening with an acceleration of 0.25 meters per second squared? Okay, so this counterweight is here because windows are typically pretty heavy, right? So if we didn't have this counterweight, when we let go of the window, it would just fall down like that. This counterweight keeps the window from just smashing down to the ground, right? Because that could seriously damage your fingers if you were to put them there. So they want us to find the force we must apply in order to open this window with an acceleration of 0.25 meters per second squared. So we know we're gonna have to find the applied force. So applied force on this window. And what other forces are acting on this window? Well, we have the force of tension and we have the force of gravity that is proportional to the second mass being, so I'll call this mass 1. So, sorry, proportional to the first mass, and this is mass 2. So this will be Fg1, and similarly for the mass 2, we have Fg2. And on mass 2, we also have a tensional force. Same in magnitude, opposite in direction to the tensional force in the first mass. So we're going to consider counterclockwise to be negative and clockwise to be positive. So visually what we're doing is, here's our Atwood machine, right? And we're stretching these strings out so that the masses are horizontal to each other, like this. And we're saying this is positive and this is negative. This being mass 2 and this being mass 1. Also, notice that the force of gravity for mass 2 is going to be less than that of mass 1. Why? Well, because this force of gravity is proportional to or related to the second mass, which is obviously lighter than the first mass. Okay, so now that we have all of that out of the way, we can draw our free body diagrams. Okay, so let's draw a free body diagram for the system. So, system. Remember, the system considers these two as one. So what are the forces acting when these two are as one? Well, we only have two forces acting, right? We have Fg2 and Fg1, which is obviously larger, right? So a free body diagram for the system would look something like this, with Fg2 being the smaller vector and Fg1 being the larger vector. So now let's draw one for the first mass. So mass 1. Okay, so what forces do we have acting on mass 1? Well, we already kind of covered this, right? We have the force of tension. We have our applied force, both acting in the positive directions. And then we have a Fg2. So this Fg2 is going to be larger than the tensional force. So this is Ft. However, when we add these two vectors together, they should be greater than Fg2 because we're going to be accelerating in the positive direction. That's why 0.25, right? We're accelerating in this way. So these two vectors have to be greater than this guy. However, we could have drawn the system the other way, right? With the heavier mass being here and the lighter mass being there. In that case, we'd have to use negative acceleration, considering that this would be moving in the negative direction. Okay, so now we gotta draw a free body diagram for mass 2. So here's mass 2, and on mass 2, once again, we only have two forces acting on it. So we have the force of tension, right? And this force of tension, it's gonna be positive. And this force of tension, it's negative. Same magnitude, opposite directions, right? Just remember, this side is negative, this side is positive. That's why the force of tension on mass 2 is negative and the force of tension on mass 1 is positive. Okay, so, and the other force we have acting on mass 2 is Fg2, going to be smaller than our tensional vector. So this is Fg2, and Fg2 is going to be positive because it is acting in the clockwise direction, which we define as positive. Okay, so now we can solve for our applied force. So which free body diagram or which mass or system are we going to use? well, the system is pretty much useless, right? It's not going to help us in any way. We can use M1, but in order to use M1, we have FG2, but we don't have FT. So we have 3 variables and only one of them given, so we cannot solve for FA. However, we can use M2 to solve for FT, then plug FT to solve for FA. So we're going to use M2 first. So M2, and we say the sum of the forces, that is equal to M2A, right? A mass 2 times acceleration. The sum of the forces being Fg2. Remember, this Fg2 is positive, plus Ft. And this Ft is negative, right? So that is equal to mass 2 times acceleration. We can say that this Ft is equal to M2A minus, we can say minus Fg2 or minus M2G. That is the same thing as saying Ft is equal to M2A minus M2G without the vector, right? Because this G is a positive, right? So positive times a negative is still a negative. We can just get rid of the vector signs. So therefore, our force of tension is equal to, we common factor out a mass 2, so that is acceleration minus gravity. We could keep it this way, but I feel like it's a little bit easier just to solve for this. So the force of tension is equal to mass 2, so mass 2 being 3 kg, times the acceleration. So the acceleration required to open the window, so 0.25 meters per second squared minus g. Plug that into your calculators, and you should get a tensional force of negative 28.65 newtons. And right, this adds up. It's a negative value. If it was a positive value, must have done something wrong, right? Because we're looking at M2. So now we're going to work with M1. And what do we notice about M1? Well, M1 has a positive tension, and M2 has a negative tension. So for M1, so right here, for M1, use positive 28.65 newtons. Okay, so M1, what are the forces acting? Well, sum of the forces is equal to M1 times acceleration. The forces acting on M1 are Fg2, and this guy is negative, plus Ft, and this guy is positive, plus the force applied, so plus Fa, and we know that's positive, right? And that is equal to M1 times acceleration. So we can say M2G, sorry, this would be Fg1. So we can say M1G plus Ft plus Fa, that equals M1 times acceleration. So let's isolate for Fa, because we want to find the force applied. So Fa is equal to M1A minus M1G. And since this is negative and this is negative, we can just say plus M1G, same thing. And then minus Ft. So force applied is equal to M1 being 4.5, so 4.5 kg times the acceleration being 0.25 meters per second squared, plus M1 again, so plus 4.5 kg times 9.8 meters per second squared, and we're subtracting positive 28.5, right? So minus 28.65 newtons. So you plug that into your calculators and you should get 16.575 newtons. So that is the required applied force to open this window and push it at an acceleration of 0.25 meters per second squared, right? Assuming that we have a counterweight attached to it.